Large language models, LLMs, have revolutionized artificial intelligence, moving from theoretical concepts to practical tools that can write, code, and converse with astonishing fluency. Far from magic, these models operate on a surprisingly elegant and scalable core principle, predicting the next word. Understanding how LLMs function requires delving into their three foundational pillars: the core predictive task, the transformative architecture, and the multi-stage training process. At the heart of every LLM is a deceptively simple goal: to calculate the probability of the most likely next token, a word, subword, or punctuation mark, given a sequence of preceding tokens. When a user inputs a prompt, the model tokenizes the text and begins an iterative cycle. It selects the token with the highest probability, appends it to the prompt, and then uses the new, longer sequence to predict the next token, repeating this process until a complete response is generated. This continuous, probabilistic chaining of tokens is what allows an LLM to generate coherent paragraphs, detailed narratives, and complex code. This predictive capability is made possible by the transformer architecture HEG, which overcame the limitations of older sequential neural networks. The key innovation within the transformer is the self-attention mechanism. Unlike previous models that process text word by word, attention allows the LLM to simultaneously consider every token in the input sequence and assign a weight of importance to each one relative to the token currently being processed. For instance, in the sentence, "The athlete couldn't run because it was injured," the attention mechanism links the pronoun it back to athlete, allowing the model to correctly resolve the ambiguity of the sentence before formulating a continuation. This ability to capture long-range dependencies is what gives modern LLMs their deep, contextual understanding of language. The sheer power of an LLM, however, stems from its intensive, multi-stage training. The first stage, pre-training BU, involves feeding the model petabytes of unstructured text data scraped from the internet, books, and public code repositories. During this unsupervised process, the model adjusts its billions, or trillions, of internal parameters, the weights and biases within its neural network, to minimize the error in its next word predictions. This process instills the model with a vast internal representation of human knowledge, grammar, style, and world facts. Following pre-training, the model undergoes fine-tuning and alignment. While pre-training teaches the model how to speak, fine-tuning teaches it what to say. This stage often includes instruction fine-tuning, training on high-quality examples of prompts and ideal responses, and reinforcement learning with human feedback, RLHF. In RLHF, human reviewers rank the quality of different model outputs, and this feedback is used to train a separate reward model. The LLM is then trained further to maximize its score on the reward model, effectively aligning its behavior with human preferences for helpfulness, accuracy, and safety. In summation, an LLM is a sophisticated system that leverages the transformer's self-attention to process language in parallel, building a vast knowledge base through massive pre-training and refining its conversational skills through human-guided fine-tuning.